Hey guys, how's it going? My name is Edward. I'm a software professional working in London, in the UK. I hold a PhD in Internet Engineering, and I'd like to welcome you to this introductory video about Git. I've been working with Git for 3 years now, and I'd like to share some of my experience and benefits of working with version control. This set of slides is designed to give you just an insight about Git, and future videos will dwell more into the practicality of version control. I think no presentation should start without throwing some bit of history. Git was created by Linus Torvalds to enhance his work on the Linux kernel just around the year 2005. Although it has its origins in the open source community, Git is also being used within closed source projects, and it works also on Windows and macOS platforms. Facebook, LinkedIn, Google are just a few of the many companies that use Git for both OSS and closed source projects. Now, what exactly is Git? Well, Git is a distributed version control system, and a version control system allows you to have different versions of a project by tracking the changes that were made to the code over time. This is highly beneficial as it allows you to backtrack if necessary and undo those changes if you have to. Some of the advantages are like everyone on your team has a complete history of the code locally. Just about everything in Git can be done offline, and is not just that the system works well when it is offline. It's designed from the beginning to have no real dependencies on a specific server. The only actions you do in Git where you need a server is when you push or pull changes from other team members. Git gives you the confidence that you can't mess things up. It's a real confidence builder, and that is really a great feeling. Every clone of a Git project is a fully usable backup, and additionally, almost every action in Git only adds data. Personally, I've rarely deleted any data. That means that losing data or breaking a repository beyond repair is a really hard thing to do. Virtually, Git arranges data like a set of snapshots of a miniature file system. For every save of the state of your project, Git just takes a snapshot of what all your files look like at the moment and stores a reference to that snapshot. To be efficient, if files have not changed, Git doesn't store the file again. Just a link to the previous identical file it has already stored. Git likes to think about its data more like a stream of snapshots. Moreover, Git has three main states that your files can reside in. State number 1, modified, corresponding to the working directory. State number 2, staged, representing the staging area. And state number 3, committed, corresponding to the Git repository. The Git repository is where Git saves the metadata and object database for your project. This is the most important part of Git, and it is what is copied when you clone a repository from another computer. The working directory is a single checkout of one version of the project. These files are pulled out of the compressed database in the Git directory and placed on the disk for you to use or modify. The staging area is a file generally contained in your Git directory, and this stores information about what will go into your next commit. It's sometimes referred to as the index, but it's also common to refer to it as a staging area. So, as a conclusion, the basic Git workflow is like this. First, you modify files in your working directory locally. Second, you stage the files, adding snapshots of them to the staging area. And last but not least, you do a commit, which takes the file as they are in the staging area and pushes them to the Git repository. And if a particular version of a file resides in the Git repository, it's considered committed. If it has been modified and was added to the staging area, it is staged. And if it was changed since it was checked out but has not been staged, it is modified. That's it for this video. In the next video, I'll show you how to install Git and crack on.